Sir.
Yeah.
Ambarish, sir. Yeah, with your kind permission, we can start, sir.
Yes. Hi, everybody. I request everyone to mute your devices so that no further, interruptions on here. Welcome. Good afternoon, guests. Myself, Anup Pillai, founder of this FCP Index. Welcome all delegates, participants to this knowledge sharing program. This is one of the first, I think this is one of the initiative by our group to boost and lighten the knowledge base of our associates working in this field of fluid conveyance. It's my pleasure to introduce our guide and mentor, Mr. Ambarish Chaterjee. He is an IITian from IIT Kanpur with a wealth of experience over 40 years in the field of hydraulic hose, fittings and assemblies. He attained the knowledge while serving Indian and global corporates like Dunlop, Gates, Eaton, say now it's Danfoss, and then Parker. He had undergone specialized training from Gates also from UK facility. Now, may I request Mr. Ambarish to start today's session, which will enlighten the delegates in fluid conveyance related subjects. Over to you, Dada. Ambarish da.
Thank you, Anup. Nice of you. So, hello everybody, and good afternoon. So, we have got 1.5 hours time, and this is basically the content. There are starting from the basics, then hose anatomy and classification, fitting anatomy and classification, the standards and specification associated with hose and fitting. Then we have a well-known short this thing called SAMT, which addresses all the parameters of a hose assembly. Then we'll talk about storage also a little bit. Let's see how much we can cover within this 1.5 hours. And we would like to be a little precise in our presentation. And if time permits, we can go in further with our contents. And if not, we can take up later date, we can finish off everything. Yeah. So any question, everyone is unmuted, muted, no? So anyway, if there are any questions, you can always put it in the chat, or maybe we can share afterwards when you are unmuted. Okay. So there we go. See, hose can be classified basically in two broad classification. One is the fluid power hoses, which is used in hydraulic circuit and pneumatic circuits, and the other is the fluid transfer hoses, or generally known as the industrial hoses, which includes all air, water, chemical, steam, fuel dispensing, refueling, suction discharge, and all those. Now, in this session, we will focus on fluid power hoses, and to that extent, mainly hydraulic hoses. First, we go into the. Is there some disturbances there? It seems. Can everyone please mute yourself? Thank you.
Yeah, I would request every participant to please mute and to please participate actively in this.
Thank you. So first we go into the hose anatomy. What is there in the hose? Basically, there are three main components in a hose. One is the inner tube, the other is the outer cover, and the third is the reinforcement. The inner tube is basically, it should be resistant to the oil or whatever media is flowing through the hose. The outer cover should resist the external aberrations like weather, fire, ozone, etc. and all. And the reinforcement is the most important part of the hose. Not that others are not important, but this is the most important, because This reinforcement, depending on what reinforcement is given, the pressure rating of the hose is concerned. Let me tell you, the tube and the cover do not contribute anything towards the pressure rating of the hose, the pressure withstanding capacity of the hose. So these are the three main, inner tube, reinforcement, and outer cover. There are other, basically this is called the construction of the hose, where you have got three, and the construction wise, if you classify the hoses, then there are braided reinforcement, which is mainly meant for low and medium pressure. The spiral reinforcement, which is meant for high pressure, and helical reinforcement is there, which is there's a helix, helical wire which is embedded between the wall of the hoses, which takes care of the suction. During suction, there should not be any collapse in the hose. So this helical wire reinforced takes care of the suction and discharge. Yeah. The third is fabric reinforcement, which is very low pressure and transfer hoses. Mainly, you can say the firefighting hoses and.
Sir, can you please get slow?
Hello.
Yeah, sir, can you please explain in a slower way? Actually, we are not able to get it.
Okay. So I started again. Braided reinforcement is basically for the withstanding the lower and medium pressure hoses. Then as we go up in the pressure rating, we have spiral reinforcement. Okay. And then the helical reinforcement is there, where you have got a helical wire embedded between the wires of the hoses, between the two layers of the hoses, which prevents the collapse of the hose during suction. So in suction and discharge hoses, like, oil suction and discharge hoses, or the suction line hoses, you get this helical wire reinforcement. Then you have got fabric reinforcement, which is mainly meant for very low pressure hoses, like the oil hoses, or, like where you do not have any pressure, where you just got to transfer the, fluid from one place to another. Then there is no reinforcement, which is basically a hose tube, or rather a tubing. Made of rubber or appropriate material. Here we have shown pictorial view of what is braided reinforcement. Here you see the first top two hoses. They have got, one has got one layer of wire braid, and the other one on the right hand side has got 2 layers of wire braid. So one layer of wire braid takes a lesser pressure, and 2 layers of wire braid takes almost the double, not exactly the double, but almost the double. When we go ask for more pressures, we go in for the spiral reinforcement. So the left hand side, you'll see four layers of spiral wire, and on the right hand side, you see 6 layers of spiral wires. Generally, these wires, whether in braided hoses or spiral hoses, these are high tensile steel wires, and we have got other fabric wires also for very low pressure hoses, where you do not require much of a pressure. There we have got fabric wire, but medium pressure and high pressure hoses, you have got high tensile steel wire. And the fifth pictorial, you see, this has got a helical reinforcement. You can see the helix, a thick wire which is embedded between the walls of the hoses. This takes care of any collapse during the suction of the material from the hose. Then if we can classify the hoses by the material of construction, you can have mostly in India, the most hoses are rubber hoses made of synthetic rubbers mainly, nitrile or neoprene. Some of the hoses which have got other, which needs other parameters, like which needs other mediums to flow, they are with EPDM and things like that. Then we have got thermoplastic hoses in two categories. One is the polyamide hoses, which are basically nylon. Nylon is the material for the inner tube and outer cover. And then we have got thermoplastic PTFE hoses. These are meant for very, very high temperature and also pressures. Then the next category is stainless steel corrugated hoses, which are meant to deliver fluid from one place to another, and the temperatures are very high, in the region of 800, 900 degrees centigrade. There we use stainless steel corrugated hoses. And last but not the least, the composite hoses. They are made of different materials to take care of, like I can give you an example of offshore mooring hoses, which are supposed to deliver oil or something like that from one place to another, but which has to float on the seawater, like mooring hoses. So they are composite hoses. These are the, we have put a small chart which is given on the vertical axis on the column, first column. It's given the, the properties of the performance of the hose, and on the rows we have given the type of resistance, different MOC of hoses they offer you. Like the chemical resistance, you have got rubber hoses, you have got a limited chemical resistance, and in thermoplastic PTFE, it is extremely good. So these are the hoses not really meant for excavator manufacturers like you, but there are some of them like the shelf life. Shelf life, if you see, rubber hoses got a decent, fair shelf life, whereas thermoplastic hoses have got extremely good shelf life. It's sort of, you can keep it for ages together and nothing is going to happen to that. Then there are other parameters like ablation resistance, thermal resistance, pressure resistance, and things like that, which are associated with these hoses. Now we go to fitting. We just go in for a fitting anatomy. Largely, if you see, a hose fitting has got three basic components. One is the stem, which call it a stem or a nipple or an insert, which goes inside the hose, which gives a support to the hose tube. And then from outside, you have got the shell or socket. There are so many names which are used in India. They call it ferrule also. So that goes over the hose, and then this socket is crimped onto the hose and nipple together to form a permanent hose assembly. I'll go to the further details. See, these are the the typical shell or ferrule or socket or outer. In different places in India, they are called differently. Some people call it a cap also, and especially in Gujarat and all, you'll find people call it outer. And so this is the shell which comes over the hose. The next is the nipple. The tail of the nipple goes inside the hose, and the head of the nipple is as per the customers or the user's requirement. These are called nipple, nozzle, inner, and things like that. Then you've got the nut, which is called nut in all the languages, whether it's Bengali, Gujarati, Marathi, English, whatever it is. So this is the nut, which is basically the third component of the hose. Now we go into a little bit of fitting classification also. These are the two type of mainly classification. One is the permanently attached fittings, which are also in general called the crimp fitting or the swage fitting. And there are some permanently attached fitting which are built-in fitting, which are built in the hose when it is built. So they are the permanently attached. You cannot take out the fitting. And if the fitting, there's some problem with the fitting, or if there is a leakage between the hose and the fitting, these have to be scrapped. The other variety is reusable, as the name suggests, and it can be attached in the field. That's why it is known as the field attachable fittings. So there you've got screwed-on fittings, then you've got bolt-on fittings. Screwed-on fitting, you'll see if you go to a petrol pump. Beg your pardon? Hello. You want me to go a little slower? Can you hear me? So the screwed-on fittings, you will see. Can you continue, please? Yeah, the screwed-on fittings, you will see these are the reusable fitting, which you can commonly see in the petrol pumps. Petrol pumps, you have got the long 4-meter hose which dispenses petrol and diesel to your vehicles. They have got the screw-down fitting, where if there is a mechanical damage on the hose, you can reclaim the fittings and then use another hose and put it again. Bolt-on fittings are generally for the high temperature lines like steam lines and all those things, where you have got a nipple and then you have got a outer casting which are tightened by 4 bolts, and that's how it remains stuck to the hose. And the last is push-on fitting. Push-on fittings are basically the simplest variety of fittings for very low pressure hoses, where you can just push the fitting inside the hose and you can use the hose as a hose assembly. See, now in any fitting like I saw you, there is a tail portion of the fitting which goes inside the hose, and there's a head portion of the fitting which gets attached to the, it can be motor port or, a manifold port or something like that. So this head side of the fitting depends on what the user requires, okay? So depending on the head side of the fitting, we have got different type of heads, like you have got an inverted flare seat or a flat seat or a flange for very high pressure hoses using spiral hoses. You have flange, and then there are staple lock fittings and all, Each fitting, they have got nuts also, and there you have got different threads. Depending on the country of origin, you have got BSP thread, UNF thread, metric thread, and so on. These are the main 3 threads which are used in hose fittings. Now we go to the hose standards and specifications. This is a very important chapter, you can say, for anyone who is making the hose or hose assemblies or using the hose assemblies. So one should know what are the standards of and specification, what are the origin and where are they at the moment. So you'll see the the equipment which were built in or which were initiated from America. They used to have SAE standard, which has got, you must be using these standard numbers, SAE 100 R1, 100 R2, and so on up to 100 R90. Each and every specification, standard, substandard they have got their own different construction and different pressure rating. Similarly, Germans, they had the DIN specification, which used to have 1 SN, 2 SN, and then for spirals, they had 4 SP and 4 SH. Then European, other countries in Europe, they had EN 853, 854, and so on. But now ISO, that is International Standard Organization, they have sort of clubbed up all the other standards to make an international standard. And this is the standard which is going to be here in India. It has already started trickling down in India, but maybe in another 2-3 years, this will be the standard which everyone will be using. I'll go to a little bit of detail in the standards. See, this is the SAE standard. The governing standard for hoses is J517. And this gives the general dimension and performance of a particular substandard, that is the 100 R1, R2, R3, and so on. There are associated standards with this SAE J517, which are SAE J343. Now, all the tests which are conducted, these tests are as per stipulations in SAE 343. 343 gives any test, for example, a proof test or a pressure impulse test or a change in length test and all. All the tests are described in this SAE J343. So especially the quality control people in your organization, they must be very conversant with this. If not, they should have a copy of this, and they should go how the tests are conducted and as per what stipulated condition different tests are conducted. Then the other associated specifications are 516, which is a hose fitting specification. Then you have got a specification J1273. This is a very important specification which recommends the practices, good practices, how to store a hose, how to use a hose, how should the routing will be, and things like that. How should the hose be routed and things like that. So this is another very important standard which should be handy with users like Hyundai. The other associated standards are given here. This is just to show that there are other standards which are associated with it, but I have taken just a few of them just to show that associated with this J517, these are the standards which are referred in J517 also. So this was the American standards. Now we go to the EN standard, European norm standards, which basically earlier there were British standard, German standard, French standards, and all. This EN standards, they have compiled, and for each construction of hose, they have come up with this EN 853, EN 854, and things like that. For example, the one which you're seeing on the screen right now is rubber hoses and hose assemblies with wire reinforced hydraulic type. So it is basically wire reinforced hydraulic type. The other standard is spiral reinforced rubber cover hoses. So this has got a different standard number. So these are, you can say, European standards and the SAE standard, the American standard. They are quite alike each other in most of the respect, apart from a little bit here and there, the pressures or the temperatures, the bend radii, and all those things. In American J517, which we call it say, I've shown this thing on the screen that is R1. So this basically, this standard gives you the what is the OD of the hose, what is the ID of the hose, what is the cover thickness, and what is the maximum working pressure. And the last column is a very important column, which is a minimum bend radius. Now for each size of say R1 hose, there is an associated minimum bend radius. This bend radius is one of the measures of the flexibility of a hose. And the instructions are like, you should not bend the hose below this, the radius, when you bend the hose, it should not go below this minimum bend radius, which is known as MBR in short. And with all associated, with each size, you have got minimum bend radius of a hose. So this is also a very important parameter along with the maximum working pressure and all those. Now, the same thing, this is depicted in a catalog. If you see, if you take a Gates catalog or a Parker catalog or a Manuli catalog, the same thing is like they put a different, their own code. This is the Parker catalog. So they call it the R1 hose, they call it 421 SH. So they have got the same parameters, like what is the hose OD, what is the working pressure, what is the minimum bend radius. Again, it's very important, as I told you. And there is another thing which I encircled with a red. This is called the impulse cycle. Now, many of you know what is the impulse cycle, but for those who are not aware of it, it is sort of a analogy to the life of the hose. There is an impulse test machine in any hose manufacturers, good hose manufacturers test lab, and what they do is they put the hose with the fitting, the hose assembly in the impulse machine, and as per SAE J343, they have got that what should be the impulse cycle, the pressure goes up at a particular rate of increase, then it stays at a pressure, higher pressure, and then it drops down. So this entire cycle is known as a one impulse cycle. So the hose assemblies are subject to several impulse cycle, and then it is found out how much of a hose, how much of a impulse cycle it can withstand. So different specification, like SAE 100R1 specifies 150,000 cycles. So if someone says that the hose is as per SAE 100R1, then it should have a minimum life cycle of 150,000 cycles. Now, there's one thing which I would like to point out. These are all comparative, for the comparative analysis. Like, for example, if a specification says that a hose should survive a life of 150,000 cycles, and there's another hose which survives a life cycle of 3 lakh cycle hoses, 3 lakh cycle impulse, that means that the other hose, which has got a 3 lakh cycle life, will give almost twice the life of the one which has got 150,000 cycles. There is no empirical formula as such where you can say that, okay, 3 lakh cycles into such an A, into B, into C will give you the year in terms of life. It is not that. So it should be very clear that you cannot straight away calculate the life of the hose in terms of weeks, months, or year with from the impulse cycle. Impulse cycle is mainly to, in the impulse machine, basically what we try to do is we try to simulate a field condition. So we simulate a field condition, and it is an accelerated test where you don't have to really wait for the machine to go to the field, then work there for 3 years and come back. This 3 years can be, it's an accelerated cycle which simulates the field condition in the impulse test machine, and then the cycle of surviving cycle of the hose is derived out from there. I know you'll have some questions here. Can some of you unmute and ask question if there is any? So, okay, we are going ahead. Similarly, you see the standard specification is like this. Parker has got a catalog like this. This is the Gates one, which actually says about similar thing. So in terms of when you see a catalog, you will see it's written, see here it is written, this 421 4SN hydraulic EN 853, this is as per EN series, and SAE 100 R1. So in any catalog, if you find Gates catalog or the Manoli catalog or Alpha Goma catalog, or for that matter any catalog, they will have their own model codes, and they will specify which part, which section of the standard it adheres to. So here, now going back to the SAE specification, which is very widely used in India today. If you see on the left-hand side column, R1, R2, R3, R4, R6, R7, R8, and so on. So initially when the specification, this standard was formed, they had specified a certain construction of the hose. For example, R1, it was one layer of stainless array of high tensile steel wire. R2 has got two layers of high tensile steel wire. Then comes R3. It's not three layers. It's a random number, you can say. R3 is two layers of textile wire. R4 is helical steel embedded wire hose. Then R6 is a one layer of textile, so that you see the pressures are very low as compared to R1 and R2. Now, in this, initially they specified the construction of the hose. Okay, that's why you'll see with the same construction, if you take, say for example, R1 right at the top, you'll see as the size goes up, towards the right hand side, the pressure rating goes down. Right? Same thing in R2, you see, as the size goes up, the pressure rating comes down. Later, you see from R13 onwards, SAE, they realized that there is no point with the advancement in, the quality of wire technology, and with the advancement of rubber and advancement of the entire hose technology. Let's not dictate the construction of the hose, but give the requirement of the, stipulate the requirement of the pressure requirement of the hose. That's why from R13, R15, you will see across the size, whether the size is going up or not, the pressure rating remains the same. Similarly, R14, you see the pressure rating remains the same with the increase in size of the hose, which was not there in the earlier series like R1 series or R2 series or R3 series. Okay. Again in 17, 18, 19, you will see the pressure ratings are the same. Now there is you may ask a question, had I been in a physical training session, there would have been a question that R17 and R18, both of them have got 21, 210 bar pressure or 3000 PSI pressure, but why they are in different series? See, one of them, R17 is basically a rubber hose and R18 is a thermoplastic hose. So all the parameters remain the same, but the material of construction and the application of the hose changes. That's why there are two different series. Now, world over, it was realized that the earlier hoses, you have got there so many different parameters, and depending on the size, the thing changes. In SAE only, there are 19 series of hose starting from R1 to R19, and in EN there are so many series and things like that. So why don't we have an international specification which is much simplified, and then we all everywhere in the world it is this specification used. This is the sorry, I keep on drinking water, so little bit of pause. So if you see this ISO 18752, this is the specification which is coming, or rather come to India to an extent, but not fully. But within the next couple of years, for sure, this will be the specification everyone will follow. So if you have started following the specification, good. If you have not, I would recommend you start using this specification and get used to it by the time the specification comes fully to India. The simplicity of the specification is very simple there. You have got a class of hose, you have got a grade of hose, and you have got a type of hose. The class of hose, whatever is the system pressure, if it is 280 bars, all the sizes in class 280 will have 280 bar pressure. Very simple. You don't have to really go in for whether it is R2 or whether it is EN 853, 854. The construction is totally left to the manufacturer, and you got to maintain across the size, you got to maintain a constant pressure. These are called the isobaric pressures, isobaric hoses. Similarly, I will go into a little bit of details where you have got different grades. In one class, say 280, you have got different grades, which is say A, B, C, D. I'll go into details. And mainly it deals with the temperature and the impulse cycle of the hose. And the third type is basically standard and compact. Standard hoses are with standard, a thick cover, and compact hoses are very compact, so that you can use it in a very restricted place where you have got a restriction of place, and from a slotted space, some 5, 6, 7 hoses got to pass through. So there you might have to require a compact hoses. So going into a little bit of more details in that, see, you have got on the top row, you have got the class of the hose, 35, 70, 140, and so on up to 560. Okay. So once you call it a class 350 hose, means across the sizes of the hose, you will have the same pressure. You don't have to really switch between R1 for 3/8 inch, R2 for ½ inch, and 4SP for 5/8 inch, and things like that. You can have the same class of hose in a hydraulic system, which will maintain the same pressure. I think it's clear from this. Now, apart from size, apart from class, each class will have a grade A, B, C, and D. Now, A, see, look at the temperature and the minimum number of cycles. A class 350 hose, grade A, will have maximum temperature of 100 degrees centigrade and a minimum number of cycle of 200,000, 2 lakh cycle. So it has to survive a 2 lakh cycle in impulse testing. Similarly, if you go to grade B, the only change is the number of cycle, that is 5 lakh cycle. Other things are the same, that is the temperatures are same. Whereas when you go to grade C and D, you will see the temperatures are elevated up to 120 degrees centigrade, and the minimum number of cycles are 5 lakh and 1 million cycle. So depending on your temperature requirement, you decide on which grade to go, A, B, or C, D. Depending on your space, you go in for the type, that is standard or compact, standard or compact. All of them have got standard or compact. And depending on your criticality of the application, you decide on the cycle of minimum number of cycles, then you decide on the grade A, B, C, and D. See, the D is 1 million cycle. So if the application is very rigorous and you have got very frequent failures, and you got to replace the hoses very frequently, then you should go in for a DC type of hose. In the same machine, there are some part of your machine which moves on a continuous basis, like in a backhoe, the backhoe side moves much more than the loader side. So the backhoe side may require a more hose with a more number of stipulated impulse cycle. So you may go in for a C instead of a A, or a D instead of a B. See, with this, with the standard and specification, we have given a this thing where for the same generic hose R1, which is equivalent to 8534 SN, all the manufacturers, the different brands, they have got different model codes. So the Gates will call it G1 or CR1 or AGR1. Parker will call it 421 SN, 422, 482, 426, and things like that. Alpha Goma will have a different name. Now within this, you may ask that, okay, Eaton has got, for R1 only, they have got 3 grades. Now these 3 grades, they all meet the stipulated pressure and minimum bend radius requirement of R1, but they have got something in special also. That's why they have got different model code for one single specification. So for R1, you have got, for example, Parker 421 SN, 422 SN. The difference is between the inner tube of the hose, which R1 and R2, they, 421 and 422, they have got the same pressure rating, same bend radius, but they are meant for a little different application. For example, 422 is required for a much volatile hydraulic oil as compared to 411. Okay, so this is basically a table which has been made for all R1s, R2, R3, R4. So different company, different brands, different corporates, they have got their different part numbers of model codes. So it's a long list going up to 4SP, 4SH and all. So this definitely you require when you are selecting a hose, and it will give you a comparative, but then you got to go in for a little bit of more detail from the catalog of the hose manufacturer, that what is so special about R12 EF G4K, and what is the difference between EF G4K and C12M. Same brand, but different model code. So for that, you'll have to refer to the catalog, but on the face of it, it is basically all of them are R12. So now we come into fitting standards and specification. Now, like hose, fittings also have standards. And in India, we have standards from, the technology has come from different part of the world, and every country use their own fittings, their own standard of hose and all those things. So ISO, International Standard Organization, they tried to normalize again. We'll come to that. Before that, we'll go in for the fitting standard, like international standards are there. SAE, DIN, GIC is also American, this thing. BS is British standard, and then finally we have got something in ISO also. Now, there are OEMs we have, those who have made their own standard, they have taken one of the standards and then modified technically and to suit their purpose commercially also. So some OEMs like Caterpillar, Komatsu, they have got their own standards. Then there are industry standards like oil and gas industry. They have got their different standard of fitting, different, strength of fitting and things like that, depending on their applications and all. Underground mines, they have got their own standard, which started from the British standard, British coal standards and all. Now this has also been covered by the ISO. Then there are proprietary standards by the fitting and hose manufacturers, like they call it a Staco fitting, snap to connect fitting, and things like that. We will mainly focus on the international standards, and we'll go straight away to the SAE, touch a little bit of BS, and maybe go to ISO. Now, if you look at the fitting as a whole, this part of it which is encircled in red, this is the hose coupling interface, which we call it. This goes to the hose end. The inner part which goes inside the hose and the outer part comes above the hose, and then it is crimped. The other one, this is the customer standard or the user end standard. It depends on what is the port like, what is the port size of the port, and so on. So the red side, the tail side of the fitting, it totally depends on the design of the manufacturer, and no standard has given any details of this apart from the major dimensions that the A and D, what is seen here. They mention the major dimension and all. Otherwise, that is a total proprietary asset of the hose manufacturer, which for the compatibility between the fitting and the hose. The front portion of the standard, front portion of the fitting is basically the user end fitting, and it depends on what is the user using and where does he want to fit the hose to. So here, SAE has got for fittings, SAE has got J516, which is their main standard. And there are other associated standards, which are, you can say, offshoots of this J516. So the J518 is there, J51, 1453 is there. There's so many of them. But we'll go to the most relevant standard now. That's why we are just not going into details of J516 at the moment. This is the standard which is the international standard against ISO 12151-1. I will go into the details of SAE standard for fittings is J516, 518, 1453, and so on. BSEN, even now many OEMs who had the original equipment from the British, they use this BS5200. But now the final standard which I was telling you is ISO 12151. Now ISO 12151 has got 6. This you people can note down also if you are not already conversant with this, those who are not conversant. ISO 12151 part 1 deals with the O-ring face seal couplings, which is known as the ORFS coupling. The part 2 is the metric coupling, which is basically the German coupling, which has got a 24-degree cone seat. Similarly, as part 3 deals with the flanges and split flanges of both varieties, 3000 psi and 6000 psi. 4 is not the one which is very frequently used in hose assemblies, this thing. The 5th one is very important, JIC, which is again an American standard, which has got a 37-degree cone seat. And BSP is the British standard, which has got a 60-degree cone seat. We'll go to a little bit of details of the standard, how to identify these. So here you can identify the fitting. You can see what we call it a JIC. It has got a 74-degree flare or a 37-degree on each side. They have got this thing. The threads used in JIC standard is UNF thread, and the female side is a flare, inside flare, and the male. Hello.
Good afternoon all. बेसिकली आप सभी को मालूम है कि नवंबर मंथ हम क्वालिटी एज अ क्वालिटी मंथ सेलिब्रेट कर रहे हैं। जैसे मैंने पहले ही बताया था, स्टार्ट ऑफ द मंथ क्वालिटी ऐसा एक फैक्टर है जिसकी वजह से हम कस्टमर को सेटिस्फाई कर सकते हैं और कस्टमर भी हमारे पास बिकॉज ऑफ क्वालिटी अप्रोच होता है। तो कस्टमर के लिए सबसे इम्पोर्टेंट पहले क्या रहता है, तो क्वालिटी रहता है प्रोडक्ट का, क्योंकि जो पार्ट हमारा उनके मशीन पे बैठता है तो उनका परफॉर्मेंस हमारे पार्ट के ऊपर डिपेंड है। तो जैसे हमारा पार्ट परफॉर्म करेगा, नॉट ओनली अस बट जो भी उनके सप्लायर है उनका सभी का परफॉर्मेंस अच्छा है ना, उनका परफॉर्मेंस इम्प्रूव कर। अभी फॉर एग्जांपल अभी हम होज सप्लाई करें तो होज का परफॉर्मेंस जितना अच्छा रहेगा।
Hello. Hello. Hello, can I continue, please?
Yes, sir. I think there was some slight confusion. I think the line is clear. It's all yours. You can continue.
Okay, thank you. So the GIC fitting type, it has the typical female side has got a 74-degree flare inside, and the male side has got a, you can say, a concave here and a convex here, convex seat here. So you see the 37-degree. Similarly, BSP will have a convex on the female end of 60-degree, and the male end will have a concave seat of 60-degree. Similarly, DIN metric, you have got, this is how you identify the fittings, and the threads are there. Okay. Now we go to the other, this thing like ORFS, O-ring face seal. This has got a flat seat and thread is UNF thread. Female looks like this and the male head is like this. So flange, there is no thread, it's a flat seat, and there's a split flange which is used to bolt two flanges adjacent to each other. Similarly, GIS is a Japanese standard which has got a 60-degree flare, that is a concave seat in the female fitting, but GIS has got both metric as well as BSP. So some of the Japanese, they use BSP, some of the Japanese, they use metric. Since this session is a overview, I'm not going into the details of each and every. Maybe on a full day session on any other auspicious day, we can go into much more detail, how to identify fitting, how to, what are the pressure ratings of the fitting also. There are so many things. What are the torque which is required to be applied on these different type of fittings and all. So you see, this is the standard. It is like this. It is mentioned like this. You give the standard gives only the major dimensions: D1, D2, hex. This is something is optional. Then this L1, L2, and L8, which is translated to a brand. This thing like manufacturer's catalog. It is like this. It looks like that. They will have their model code for their fitting, and it is written ISO 12151-5. So it belongs to this category. Okay. So this is just to give you a feel of how they are translated into catalog. Similarly, 45-degree bend. This is the catalog, which gives you the major dimensions. And from that, you got to find out what you require. Same thing here. This is a 90-degree fitting, and it is translated into catalog. Now we come to a very important this thing, how complete, when you are buying your hose assembly from someone, or when you are describing your hose assembly, this stamped word is a very important word, which is used by most of the global hose manufacturers, and each has got a significant significance, and all of them are very, very important to understand. S is for size, T, temperature, application, medium, pressure, end fitting, and dressing. This depicts the entire hose assembly. Anything which is missing, that means you have not done full justice to the hose assembly. Now, size. See, in hose, there used to be different, again, from different countries, there used to be half-inch designation, 12.5. Some people used to have NB 12.5, NB 12, NB 13, and things like that. Finally, now, the globally acceptable size description is by dash size. So, this is like, for example, dash 301-10. Now, what is dash 10? Any dash number is equivalent to 1/16. One dash number is equivalent to 1/16 of an inch. So a dash 10 is 10/16 or 5/8. So all these hose and fittings, they are now described in terms of dash sizes. No longer this NW and DN and NB and things like that. So a dash 16 is basically 1-inch hose. Fine, 1-inch ID hose. Dash 12 is a 3/4 inch ID. I mean, you divide the dash size by 16 and then you get it in inches. Now, this is mainly for the designer. I don't know, some design people also must be sitting there. And we can talk on this for hours and all. But then I would not, since it's just a overview of the thing, the design, the size of the hose is basically governed by this parameter. Maximum recommended velocity in feet per second. For a return-like hose, it is 10 feet per second. For a suction-like hose, it is 4 feet per second. And for a pressure line hose, it's 20 feet per second. Beyond this, if you go beyond this, in a pressure line hose, if you go, say, for example, 25 feet per second, there'll be a lot of heat generation. There'll be a possibility of cavitation. There'll be a possibility of, so many things. So, these are the recommended maximum velocities. So one should not, while designing, while arriving at the size of the hose, you should be very careful about these recommended parameters. We have got a nomograph on this, which is a very simple nomograph. On the left, there are 3 vertical lines. Left line is the flow of the fluid, and the last line is it's the inverse scale. So from up to down, you will see the velocity is increasing. So this is the velocity scale, and the first one is the flow scale. Now, depending on the flow which you know for your machine, you draw a line to cut the maximum recommended velocity of, say, pressure line. So wherever it intersects the middle line, that is the size of the hose. I'm sure the design guys must be using it, but again, for those who do not know. So similarly, if it is a return line hose, you got to join this 10 with this, and then wherever it intersects, you get the return line diameter, internal diameter. Now, what do you do? Like in this case also, this intersects between 5/8 inch and half inch, then what should you select, 5/8 inch or half inch? The the commercial half inch, because it'll be cheaper. But technically, we'll go to the next slide and see. If we select half inch, then this line, the red line, it passes through half inch and it intersects the last vertical line at a velocity which is more than 20 feet per second. So this is out of recommendation. But the green line, which if you select 5/8 inch, it passes from it comes to about 16 feet per second, which is within the recommendation. So in case of an intersection between two sizes of hose, you should always select the higher side of the hose. Now we come to the stand temperature, T temperature. Temperature, this is general rubber hose temperature range. Now this temperature, mind you, which many people, especially in the process industry people like the steel plants, the aluminum plants, they always think the temperature which we talk about is the ambient temperature. And sometimes they ask us, कि भाई हमारे इधर तो temperature बहुत अधिक है, आप मेरे को high temperature hose दीजिए. The thing is not the outer temperature, not the ambient temperature. It is the fluid temperature which we talk about here. So for the petroleum-based fluid, the general hoses, the general rubber hoses, which are standard rubber hoses, not a high temperature hose, they are from minus 40 degrees centigrade to plus 100 degrees centigrade. अब कुछ लोग ऐसा सोचते हैं कि if it gives petroleum में ही अगर 100 डिग्री तक होता है, तो why can't we transfer water? See, you look at this. For hot water, it is much lesser. Only 70 degrees centigrade maximum is allowed, right? And for water glycol and all those, only 85 degrees centigrade is allowed. So it's very important to select a hose. After selecting the size, you go in for what is the temperature, what is the fluid medium you are using. Depending on that, you should choose a standard hose or a high temperature hose. Okay? Because what happens is, you can use, it's not that you cannot use hose at a higher temperature. I mean, say a water hose, hot water for this hydraulic hose you can use, but the life will be shortened. The life will be shortened, and we have got in our next this thing we'll see how does the temperature affect the hose life. You see this is not a very clean, clear this thing, but this gives you a temperature. Here's the hose by number. It's one of the manufacturer from whose catalog we have taken this thing. And you see a particular hose, a particular, for hydraulic based oil, it is 150 degrees centigrade, whereas for air, it is only 70 degrees centigrade. See, for water, it is only 85 degrees centigrade. So assuming that it can go up to 150 degrees centigrade of hydraulic oil, we can use it for water? No, we cannot, not even for air. So this one has to kept in mind, and then you can use a hose manufacturer's catalog and find out which hose gives you how much pressure for which medium. Then in the stamped word, we come to ST, we have completed size and temperature, we come to application. Now, a particular hose which can give a very good life in a standard static application with normal temperatures, not much of a surge in the pressure or whatever it is, but depending on the application, your this thing varies. I'll just show you a couple of graphs which will explain what I mean. See, this one is the peak pressure effect on hose life. Okay, you see the recommended working pressure is say 100 bar. Then, and you are using at a say peak pressure of say 150 bar. Okay, the hose life is reduced by almost, it is initially you are getting at a hose recommended pressure, you are getting 400 impulse cycle life. It comes down to 100 impulse cycle, one fourth of the original life. So more the peak pressures and higher the peak pressures, you get this effect. If your peak pressure is 150% of your working pressure, you get almost, here you see, it comes down to 50. So almost 1/8 of your original life. So more the peak pressures are, higher the, lower the life cycle is. See, if you see, Anup knows it very well, much better than what I know. He has been using this, he has been supplying it to, his hose assemblies to, the rock breaker attachments, where you have very high, very frequent and high peak pressures. And that's why the same hose, if you get it in a static application, you get a life of say 1 year or something like that. These applications like a rock breaker application and all, this gives you 15, 20 days, 1 month life, maybe 2 months life, that's all. So peak pressure is very important, and it affects the life of your hose in that application. Second is your flexing of the hose. If the hose is flexing, then this is a graph that on the x-axis you will see the flexing angle. Okay, so depending on how much the hose flexes in the sense, if you take one of the end, if you take it static and the other end is moving, then you see how much of movement it is there in terms of degrees. Okay, and depending on the movement of degrees, say, for example, here we are given an example of 70-degree movement. So corresponding bend factor is 1.2. This bend factor has to be multiplied with the MBR column, MBR of that particular hose, and then only you find out the allowable MBR. That suppose a hose has got a minimum bend radius of 100 millimeter, but it is flexing by 70 degree. Okay, that means the bend factor is 1.2. So that now you are not allowed 100 millimeter to bend. You can bend it only up to 120, not beyond that. The third factor is the bend radius. How much do you bend? If you go to these application factor, vibration, mechanical shock, fire, spark, abrasion, and all, we are here taking 3 factors, main factors. Now this is the bend radius factor. So in bend radius factor, you see, if you bend it as per your bend radius, then you are getting a, say, 100% life, or we are taking it to 90-95% life, something like that. If you bend it half of its bend radius, here, you see half of its bend radius, the pressure efficiency and correspondingly, consequently, the life of the hose is reduced by almost 23%. Almost here, yeah, about 23%. So this is very important. This is very important to see. That's why you'll find in the catalogs of the global hose manufacturers that they have said that our hose is a half bend radius hose. That even if you bend it to half the recommended bend radius in the specification, standard specification, they will give a full life. They will give a full life. So they call it a half bend radius hose. So they stretch the life up to here. So even if you, so if it is a standard hose, then you got to be very careful about the bend radius factor and design your entire circuit accordingly. Then comes the, after STAM, M is the fluid medium. Now again, like I was telling you, the fluid medium is very important for, you know, for your selection of hose. Now, when I was telling you that for R1, some people have got 2, 3, 4 varieties of hoses. For R2, some people have got, some manufacturers have got 2, 3, 4 varieties of hoses. This is because of the change in medium, change in application. So medium plays a very vital role. Okay. So to have a hose for just your ordinary, most used enclosed 68 grade oil or even 45 grade oil, you can have a standard hose. But if it is for some other, even the eco-friendly fuels nowadays, which are used to quite an extent, you require something special, which you can get from the different variety of the hose from the same subgroup. Here's a chemical resistance chart. Here you can see the chemical which is used, say in a, this you will find in any global good catalog. Everywhere you will find, every hose manufacturer, this gives you the how good or the bad the hose is with that particular chemical, right? So the fluid medium is very important. If you do not use the right, this is a very, we have shown, given an example of a fluid medium, which is a little volatile than the usual hose, or which is some gaseous fluids are used. You will see some blister coming out on the surface of the hose, which is because of the improper fluid medium used for a hose, or improper hose used for a fluid medium. See this sort of blister, if it is a fluid, is incompatible with the hose material. Here it's written, phosphate ester is the material, so it is giving this sort of blister. Now come to the STAMP, pressure. Now these pressures are of, you know, there are many names of pressure. One is, say, maximum operating pressure. This is the pressure which you can call it a pressure rating of the hose, because the manufacturer of the hose specifies this pressure as the operating pressure or working pressure, whatever it is. The design pressure is known as the burst pressure. The hose is designed, the hydraulic hose is designed at 4 times the operating pressure, or the design pressure is 4 times the recommended pressure, right? So the pressure at which it is designed is known as the burst pressure divided by 4, and that becomes the recommended operating pressure. Now there are other pressures which are used in impulse cycle. The pressure is different, which is given in the specification. Approved pressure is generally 2 times the maximum operating pressure at which you can test all your hose assemblies if you want to, if you are, you know. And then in the pressure, we would like to mention that there is a thing called pressure drop, which you are very aware, anyone is aware. And these depend on the hose fluid, temperature of the fluid, hose size, flow rate, and all these factors which have been listed down. So pressure drop has to be kept in mind while designing your hose, or especially in applications where the hoses are very long. You know, there are certain applications where the hose with the joint, with several joint. The other day I was with one of my old customer. I was talking to him, and they are in the underground mining sector, and they use a hose reel, which is by using joints, it is 1.5 kilometer long hose reel. it's in a high wall mining machine. So there you can imagine the pressure drop from the back end to the front end. So this pressure drop has to be kept in the mind. Now, there are certain questions which have come up in many of my training sessions, that if your hose is designed for a burst pressure which is 4 times the maximum operating pressure, can't we use it at a, say the maximum operating pressure recommended is 1000 psi, and the design burst pressure is 4000 psi. Why can't we use it at 2000 psi? It will not fail. You're very right. It will not fail. But then I'd like to show you one small graph which will give you the idea. See, here the actual working pressure, recommended working pressure is 100 bar, right? And the design pressure is 400 bar. That is the burst pressure, right? Here someone wants to use it at 150, which is only 50% higher than the recommended working pressure, whereas the design pressure is 400 times higher, 400% higher. So if you use that even at 50% higher, your life is reduced by 70%. See, can you see this? At 150% of working pressure, your hose life is reduced to 30% of the earlier life. So you have lost 70% of the life. So there comes the question of using a pressure or a hose at a pressure which is higher than the recommended pressure but lower than the burst pressure. The global hose companies, the leaders in hose, they generally, that is the reason, they generally validate their hose at 500% to 600% of the recommended working pressure. The effect is here. So if it is validated at 600%, okay, then even if you use it at say 150% of your working pressure, it will give a full life. So basically, some people will say it is an over design, but no, it is not an over design. It is the tendency of some users who use, especially in the industry, in the process industry, the steel industry, the metal industries, where they have got a tendency of, okay, this hose is ruptured, why don't we change it with another which is lying in the stocks, and that if that has got a burst pressure of say 400 bar, we can use it at 150 bar. So they use it, and that is the result. So that is why some global hose manufacturers, they validate their hoses at much higher pressures. I'm showing the other same thing again. Then stamped E is the end fitting, and then the standards which I have already talked, I'm not going to repeat it again. Then storage is a big thing, ISO, even our SAE, everyone says that the storage of a rubber hose, if it is stored properly, can give a lifetime of 40 quarters, that is 10 years. But it has to be stored ideally. These are the different parameters which I'm not going into the details of it, but this reduces your storage life substantially. And that's why in practice, whenever we were asked that when should we replace the hose, we always tell them that you have to replace the hose. If it is not a very critical application, you can take it up to 2 years. After 2 years, you should replace the hose. And, you should see whether you are using a hose, whether it has developed any crack or something like that. If there is any crack, then you should not use it. If there are no cracks and all those things, then probably you got to test it on a proof pressure level, and then you can use it. So 10 years on paper, it's written, but that is ideal condition. And because there are so many things which are there, ultraviolet light is one thing. So many hoses which lie on the, nobody can store a hose in a cool, dry place, which is generally written in a medicine bottle or something like that. So these are the storage. Then we come down to the, just a second, I'm missing one. D I'm missing, where, I don't know. Just a second here. There's one more missing. Anyway, we have missed that somehow. There's a slide on, what are the dressings, which in your case, it's not applicable to that extent. Yeah, you use in your vehicles, you must be using the, anti-abrasion sleeves or heat sleeves. You may be using heat sleeves on the hose, which are very near to your radiators or engine or touching the engine and things like that. So that completes the stamped, STAMPED. Okay. So next, what is the time right now? We are running out of time. These are not going to be useful for you. There's another thing called pressure efficiency and hose derating. This we can take on a separate session when we talk to the designers, hydraulic circuit designer of your company, who are deciding on the pressure efficiency of a hose, like they derate the other components, hydraulic components. These are all also, hoses are also derated, mainly depending on the MBR, temperature, and fixing. So this we are not going to take up. We have other things also, which I think the time is not permitting at the moment. But just to show you this slide. The failures, the field failures, which comes to you must be once in a while, if not very frequently. They are mainly for these main reasons. One is the improper use. Second is, improper use where the fluid is something else, or the pressures are different, or lengths. Lengths are also, they take a very vital role. The failures, 22% of the failures can be attributed to these improper selection. In length, what I wanted to say, a hydraulic hose is allowed to shrink by 4% of its original length. Now, if you are using a hose very tight between two ends, between two terminals, then, and if the hose shrinks by 4%, then you had it. So your fitting will come out of the hose, and you might have seen such failures reported from the field, which is basically due to inadequate length. So what we generally recommend, that the hose can shrink by 4%, or it can expand by 2% also. If it expands, it's not going to really harm you. But if it shrinks by 2%, then there are all possibility that it comes out of the fitting. So we recommend a 5% additional length for any hose, provided it satisfied. If it is excess length, sometime the kink may be there, the misalignment may be there. The second point which we are coming on, the improper alignment. See, this twist in a hose or a sharp bend in a hose just after coming out from the fitting, that adds to 19% of the failure. Improper routing. If the bend radius are not followed properly, the elbows are not as per required. Sometimes you put a wrong elbow, it should be straight. You put a wrong elbow fitting, or vice versa, and that gives rise to 9% of failures. Hose and fitting mismatch. If the hose and fittings are not validated, see, you can have the best of hose under the sun of a brand and have a fitting of best of fitting of a different brand. If they are not validated together, there can be a hose and fitting mismatch. This is a very, very predominant phenomena in India, where the hose and fitting are mismatching, and there are almost 1/5 of the failures are because of that. See, about 19%. For excessive temperature, 3%, and for improper hose assembly, crimping, orientation, that contributes the most, that is 28%. So these are the reasons for hose failures. We have got a full chapter of how can the failure look like, what are the remedies, what are the solution, symptom, cause, solution, but all these will take this proper installation is a very important thing. See, this shows that your hose should come out at least 2 OD of the hose after your fitting, then only it should bend. So we have got a total routing, this thing. These are the torque for different fittings, like BSP fitting, the torque table is different. The GIC fitting is torque table is different, and so on. So there are a lot of things. There are a lot of things which probably cannot be covered in this sort of small listing. Only the one last slide, which I always show to any training session or any webinar or any seminar for that matter, is this picture, which people down the line who are fixing the hose, sometimes there can be a pinhole in a hose and an invisible jet of hydraulic oil will be coming out, and if it is carefully not dealt, people generally try to figure out where the leakage is from, and they use their naked hand, and this happens. And consequently, there have been cases where the hands have to be amputated, and in cases some people have died also. So
Ambarish sir, Abhinandan sir wanted to say something. He raised the hands.
Okay, sure. So it is the last. So you can always raise any questions. That is one thing which I enjoy during my physical presentations. Yes, Abhinandan.
Yes, Ambarish, you have so well demonstrated that the probable attributes
Right.
for the hose failure. So
Right.
it would be very helpful from the point of view of production, assembly, as well as QA, if
Right.
you can demonstrate it further with the help of some photographs, some okay and not okay.
Yeah, we'll do that. We have got that. I just Anup has made a very good this thing for me, which I could not include in this. But here you see, this should be taken care of. Then one of the biggest thing as you read this, if you twist the hose, this is very important for the people who are installing. Sometimes they over tighten it and install it in such a way that the hose is twisted. Now you can make out the level of the hose. If it goes in two different dimensions, two different level, that means there's a twist in the hose, and like it is written, a twist of 7 degrees can reduce its life by 90%. So you can be sure, if there is a twist, you can be sure of having a warranty return. That is for sure. You can surely have a warranty return. And we have seen in many cases, I had been to many OEMs, which I cannot name, for their installation sign-offs, and we have found out that most of the warranty failures are because of the twist. Most of the warranty. So we will give you a do's and don'ts, which is the correct way of installing it, which is the incorrect way of installing it. And you can take a leaf of that. and then
Point very well taken, sir. We would be very, happy if you just share some slides showing this type of, some good practices or some potential failures might be, so that we can, share it down to the line to the operator level. We can there have some OPL installed there, and that will act as a deterrent for the operators to, understand and appreciate the routing as well as the twists which you have mentioned.
See, the failures can be because of three major reasons. I do not have a slide right now here. Three major reasons. One is the defect in the hose or fitting itself, okay, which you cannot help. You have got a defective hose or fitting, okay. The second is the wrong choice of hose and fitting, right, where you can have failures like this, which are compatibility problem or something like that, failures like this, okay, which I can share with you, no issues. And the third is installation. In installation, you got to find out there are two main reasons of installation failure. One is the twist in the hose, and another is subjecting the hose below the minimum bend radius. Okay, so these are the two things which the installation people should keep in mind. The moment that find that you are bending the hose a little too big, if you are in doubt, you can use some cardboard templates, which generally everyone does, to see whether they are overbent or not. So these are the main two reasons. Number one is bend radius, bending it more than the bend radius, and another one which is more prevalent is the twist. Okay, so these are two things. And third is of course over torquing. If you are using a torque wrench and all those things, that is eliminated. But these are the three main reasons. I will definitely share some this thing.
Sorry to interrupt. Yes, we can, Abhinandan sir, we can share a few slides, do's and don'ts while assembly and while bend.
Right.
Even we can help you with wherever you need double hexagonal to avoid the twist, and those all we can share you. Means maybe in another week time, we'll make a see the feedback form is coming to you. So you can mention whatever you require on that, so that we'll share it to you.
Right.
No, there was some, I think that the organization requires some good example of good practices or good,
good practices,
things that we can always horizontally deploy it in all our.
Sure. That can be
in the field.
The feedback form is coming to you in another 5-10 minutes. So you can mention whatever you need from us, whatever the things you need, so that we'll share it with you.
Yeah.
Okay. Sure.
Thank you.
Anything else?
Carry on, Dada.
No, I'm over. I'm through. It's 1.5 hours, I was told.
So Abhinandan sir, can we conclude for the day?
Yes, this training has been very well taken by all the participants, and I would like to personally thank each one of you for attending the training, as well as for Ambarish sir as well as Anup sir for conducting this interview. And we hope that we will have many such interviews and many such interactions in future. And it is very well if in future you can personally come down to Hyundai and you can conduct in-person training with us, which will be much more effective and much more it will be.
Yeah.
So as I have already discussed with you earlier, sir, Ambarish sir, I hope and I want you to be present here in Hyundai sometime soon, and we can take this further.
Right, sir.
Thanks a lot. And you can always, even after this, if you have got questions, you can always write mail to Anup or me.
Yeah, it is already, the feedback form had already reached your mailbox now.
Okay, great.
So they can post their queries, whatever the comments, so that we can reply to that personally.
And thanks to everyone to have attended my training. And my apologies if I've been a little too fast or whatever it is. See, this is what happens in, this is not the first time in web training and web seminar and all. But until and unless you see the body language of the audience, you really do not know where to put more stress on, where to put more time on, and where to skip, like you can always make out. This is unfortunately, we do not have that sort of a, but courtesy Corona, we have to do it. Next time, definitely by this time, things have gone down. And so my thanks as well as apologies for.
No, no. So, Anup sir, I would request you that you can send us some modules, just a topic, so that we can take it further and we can have an internal discussion and get the necessary approvals.
Right, sir.
So that we would be able to see you in person, and it will be very well taken. Like sir rightly said that what is the requirement of the audience actually is evident.
Exactly, that's the point of giving the feedback from
here,
that, sir. Let that also come from the guests, the delegates, so that it will be we can present something little expansive.
Correct. So I hope we have actually this training has fruitified very well.
Right, sir.
And sir, can we share the slide, or is it a sole propriety of your organization? Like, what is the policy about it?
Yeah, it is quite a bit of quite a bit of compilation and all those things have gone. But if you require some relevant portion of the slide, I can definitely, we can share those. Like the numbers and all those things. Those slides. If you can just write it down, what are the slides you would like to have? We can send you a.
Sure. So what we can do about is that we can have at least the hose routings and the hose fitting.
That we can do.
So those things, even a small present of small slides, number of slides will be very helpful as far as the.
Anup, I think the one which you have sent me, the made one, which I could not, paste it here. I should have been.
Yeah, I'll share it. Means let the feedback comes. I'll
compile
it and
you can share the do's and don'ts.
Right, sir.
Yeah, some simple basic procedures which we might have overseen it, which we might not have been taken in consideration. It is possible. It is. I'm not wishing it away. It might be possible, sir.
Right. We'll share it. We'll share it.
Okay. Thank you, sir.
Yes. Thank you. Great day.
Thank you all.
Thank you, sir.
Great day ahead, sir.
Thank you.
Thank you, sir. Dhanwad. Thank you.